I want to configure private VLANs on DSW2 right now. Notice how we have DNS1, DNS2, file server 1, and file server 2 in VLAN 200. They're in VLAN 200. They all are part of the 10.1.200.0/24 network. So if we go to DNS1 as an example and issue a ping to 10.1.200.51, which is DNS2, communication is successful. What about file server 1? Communication is successful. And file server 2? Communication is successful there as well. What about between file server 1 and file server 2? Let's do a ping to 10.1.200. File server 2 would be 53. Ooh. All right, so we have successful communication there as well. I want to implement private VLANs to control the traffic that's flowing between these devices. What I'd like to do is I'd like to make sure that DNS1 and DNS2 can still communicate with each other in VLAN 200, but not with file server 1 or file server 2. I want to make sure that file server 1 and file server 2 can't communicate with each other at all, or with DNS1 and DNS2. So DNS1 and DNS2 are going to be in their own community VLAN, and file server 1 and file server 2 are going to be within the isolated VLAN. So let's start carving all of this up. Now, first and foremost, we are not running VTP version 3 here. So I need to change my VTP version to transparent mode. And it's not VTP version, it's VTP mode. VTP mode, transparent. So we're not running version 3. Therefore, we are currently running version 1 because we haven't changed it to version 2. So we need to be in transparent mode because the private VLAN information is not propagated with VTP version 1 or 2. So we changed our mode to transparent mode. Now we can create VLANs for our private VLAN implementation on DSW2. If we were in server mode, we would then have an issue with that VLAN information and the other devices within the topology. So we have to be in transparent mode for private VLANs, unless we're using VTP version 3. So VLAN 200 is already created. Show VLAN brief. And gigabit 21, 22, 23, and 24 are all part of VLAN 200. But we need to change what VLAN 200 is. We need to change it into a private VLAN, and we want it to be the primary private VLAN. So if we look at the output of do show VLAN instead, and we go all the way to the bottom, you'll see that there's a section for primary, secondary, type, and ports. This is where we can verify our private VLAN information. So let's go ahead and type in here, do show VLAN, private VLAN instead, and it's just going to give us that output. Show VLAN private. So let's change VLAN 200. VLAN 200 is going to be a private VLAN, and it's our primary private VLAN. We are going to use VLANs 401 and 402 as the secondary VLANs. So let me show you what happens if we try and do an association right now. Private VLAN association, 401 and 402. Command rejected. Invalid private VLAN association between VLAN 200 and VLAN 401. VLAN 401 data is not available. We need to create VLAN 401 and 402. That's what we need to do. So let's do that right now. VLAN 401. And what type of private VLAN is 401 going to be? VLAN 401 is going to be our community VLAN. That's the one that we're going to put the DNS servers in. So we'll type in community. And now VLAN 402, we are going to set up as the isolated VLAN that will put file server 1 and file server 2 in. Now let's do our mapping for VLAN 200. And it was private VLAN association 401, 402. Now the command works because those VLANs exist. Let's verify to make sure that everything has been configured successfully. Show VLAN. All right, we'll do it here. Show VLAN, private VLAN. We can see that the primary VLAN is 200, and we have a secondary VLAN. It's a community VLAN associated with it. And we have another secondary VLAN 402. That's an isolated VLAN associated with it as well. But notice there's no ports. There's no ports associated with our isolated and community VLANs just yet. So let's do that configuration now. Configure terminal. And let's focus on DNS1 and DNS2 right now. Those ports are Gigabit Ethernet 21 and 22. So we can use the interface range command since they are both going to have the exact same configuration. So interface range, gigabit 1/0/21 and 22. Now, remember that they were originally configured with the command switchport access VLAN 200. We should remove that because we are going to be changing their mode right now. We are going to be changing them into a switchport mode private VLAN host, and they're going to be associated with the primary VLAN of 200 and a secondary VLAN of 401. So let's remove that command. No switchport access VLAN 200. And now we're going to type in switchport private VLAN. And what do we want to do? We want to say that we are associated with, so our host association, VLAN's what? VLAN's what? Well, the primary one is 200. So that's what it's asking for first. And then it's asking for the secondary VLAN. And what did we say was the secondary VLAN? Do you remember? Let's go back up. In this case, it's the community VLAN for DNS1 and DNS2, and it's 401. So we have to say that it's part of 401, the community VLAN. Now, what is the mode here? The mode, so switchport mode, is going to be now private VLAN. Private VLAN. And what are we? Are we the promiscuous port? No, we are the host port. So switchport mode, private VLAN host. All right, let's see how that worked out. Show VLAN, private VLAN. Look at that. Now gigabit 21 and 22 are part of the community VLAN 401 that is associated with 200, the primary VLAN. It's perfect. So now we want to configure /22 and /24, which is connected to file server 1 and file server 2. Since they're both part of the isolated VLAN, we will be able to do the configuration together because they're going to have identical configs. So interface range, Gigabit Ethernet 1/0/23 and 24. There we go. So first and foremost, let's remove no switchport access VLAN 200. And now let's start doing our private VLAN configuration. So switchport, private VLAN. Here's our host association. And what is the primary VLAN? 200. And what's our secondary VLAN? In this case, what is it? It's the isolated VLAN we want, which is 402. 402 is the secondary VLAN. It's isolated. So we're isolating file server 1 and file server 2 from each other and the community VLANs. Now we also have to indicate that a switchport mode is private VLAN, and we are a host. We're not the promiscuous port, we are host. And let's verify our configuration now with the show VLAN private VLAN command. And whew, so far, so good. So far, so good. Let's do a little test right now. Let's go to DNS1. And on DNS1, let's ping DNS2. Let's see if we still have connectivity between the two. And we should. My fingers are crossed that I did everything right in the background so far. So our ping is going to be to 10.1.200.51. It works. It works. Now let's try one of the file servers. 52. Oh, perfect. It fails. That's what we wanted. That's what we wanted because DNS1 is in a community VLAN and file server 1 is in what? It's in an isolated VLAN. So we've prevented communication there. What about between DNS1 and file server 2? Excellent. Fails there as well. So we've accomplished our goal of making sure that DNS1 and 2 can still communicate with each other, and they are not able to communicate with file server 1 or file server 2. But can file server 1 and file server 2 communicate with each other anymore? They shouldn't, because they're both within isolated VLANs. And they can't. They can't. Excellent. Excellent. So we've accomplished our goal within the private VLANs. However, can any of these devices communicate beyond their primary VLAN of VLAN 200? Let's do a test by pinging PC4. So PC4 is 10.1.1.74. So that fails for file server 1. Let's go to file server 2. Ping 10.1.1.74. That fails for file server 2. Let's ping 10.1.1.74. That fails for DNS2. And lastly, we'll do a ping for 10.1.1.74, and that fails for DNS1. All right, so it's failing for all of them. Now, why is that? Why is that? Think about it. Have we identified the promiscuous port, the port that goes up to the default gateway? No, we haven't. We haven't defined the promiscuous port yet. Who's going to be our promiscuous port on DSW2? Think about that. Examine the topology right now. Who is the default gateway for VLAN 200? It's DSW2. We are the default gateway. So all of these devices are directly connected to the switch that is their default gateway. Interface VLAN 200, 10.1.200.1. So how do we make an SVI a promiscuous port? Can we even do that? Yeah, we can. We can do that. And I want to show you that here today. So we'll go into global configuration mode, type in interface VLAN 200. And since interface VLAN 200 is already associated with VLAN 200, we only need one command. And that is the private VLAN command with the mapping keyword. And then we specify which secondary VLANs we are the promiscuous port for. Notice what it says there. The secondary VLAN IDs of the private VLAN SVI interface mapping. We do not have to specify that this is a promiscuous port. We don't have to, because it's an SVI. It is going to be a promiscuous port no matter what. It's a layer 3 interface. It's not a layer 2 port. It's a layer 3 interface. So let's just define the two VLANs. What are they? 401 and 402? So 401, all right, comma 402. Let's see. All right, it's happy with that. All right, creating a private VLAN mapping between 200 and 401 and a private VLAN mapping between 200 and 402. Private VLAN mapping for 200 and 402. Excellent. All right. Did it work? Let's check it out. Let's make sure it works. If everything is correct now, we should be able to communicate with PC4 now. Why? Because the promiscuous port is interface VLAN 200. Interface VLAN 200 can route for us. Therefore, we should be able to communicate with PC4, and we can. And we can. Does it work on DNS2? Oh, not working there. There we go. Woo! All right. Had me a little worried there. File server 1. Connected to an isolated port. Come on, there we go. That one worked as well. And lastly, I'm pretty sure this one's going to work. But just to show you it works, let's watch it. Come on, there we go. So perfect. So that is our private VLAN configuration. Now DNS1, DNSW2 is in a community VLAN, VLAN 401. File server 1 and file server 2 are in isolated VLANs, or the isolated VLAN 402. Therefore, those two different types of VLANs can't talk to each other. In addition, because file server 1 and 2 are in the isolated VLAN, they can't talk to each other at all. So we've accomplished our goal of keeping the same VLAN, keeping the same IP addressing, but then just breaking up that VLAN to control the flow of traffic.